All right, so the next topic we covered was mass movements or mass transport. And we really just talked about the different ways that mass or rocks and sediment and fluids are transported at the surface. In general, all of them are related to gravity, right? But there are different styles of mass transport. And so these first few videos here show kind of a large hillside slumping. That's kind of what's happening there. We would call that a slump. Um, this is more of a channelized flow. It almost looks like a river, but you can tell there's tons of debris in there. There's a giant boulder there. It looks like the size of a Volkswagen Bug or something like that, maybe a little smaller, but it's a huge, huge block, right? Tons of material being transported there, but it's flowing continuously in kind of a linear or laminar flow, right? And if you looked at a larger scale, it would be channelized, right? It's not flowing like that forever. There are boundaries, and it's more or less confined to a channel. This one is totally different. This is just rocks falling straight down, right? And so we would call this a rock fall. You can see the whole hillside kind of gives way and just falls straight down. All three of these obviously have to do with gravity. That's the force that's propelling them. But they're three really kind of morphologically different styles of rocks falling. This was another nice rock fall. And we also looked at this video here of this whole piece of land, which is at a really kind of shockingly low angle. It's not a very steep angle that it's sitting at. Nonetheless, the gravitational forces are great enough to cause this whole piece to just slide off into the ocean. Lots and lots of damage. Okay, on the topic of damage, we talked about this town, La Conchita, on the California coast, that suffered from two really catastrophic and really very different forms of mass transport. Initially, in the 90s, there was a slump, kind of classic slump geometry that caused quite a bit of damage in town. And then later in the early 2000s, there was a debris flow that caused unconsolidated material from that slumping area to flow downhill in this kind of channelized flow down into the neighborhood. Okay, they can cause, debris flows or mass movements in general can cause tremendous damage, and so they're a topic of great interest in terms of humans dealing with the environment around them. They present a large hazard. Characterizing them, you can have kind of sliding type of behavior versus flowing type of behavior, and obviously falling. A rock fall is more or less a rock just falling straight down like we saw. But slides kind of suggest that there is a plane on which the majority of transport is occurring. And that's true, right? And so there are a few different types of slides. We can have block glide or an earth slide. That's like that big piece of earth that slid off into the ocean. What happened in La Conchita initially was more of a slump, and it has a particular geometry. We'll look at a couple of pictures real quick of that. Slumps are slower when compared to something like a block glide or an avalanche or a mud flow or debris flow. That was kind of captured by those first videos that I just showed. That debris flow looked like a river, like a raging river flowing. Okay. There's also this phenomenon called creep, which is the slowest type of mass transport, and it really results in just kind of like the slow bending over and downhill transport of material. All right. All of this has to do, again, with gravity. There's some amount of friction where a rock is contacting whatever exists beneath it. In this case, these small contact points, and there's friction on that surface, right? But if the topography is sloped, gravity is pushing downward, which means that some component of it is pushing perpendicular to the slope. We'd call that normal force. And some component of it is actually pushing downhill, right? The way that this breaks down, if you do the trigonometry, is that if the slope is at 30 degrees, about half of the rock's weight is actually force that's pushing down slope. Okay, so that can pretty easily, as you imagine, even at 30 degrees, that can the downhill force can overcome the frictional forces. And it's really a competition between those two. There's a couple of different you know things showing that, but there's a bunch of stuff that can influence how cohesive rocks are or sediment is. Water is a major factor. It can act to both stabilize and destabilize, right? And so a sandcastle, you're able to have these 90-degree straight vertical walls on a sandcastle because of the cohesive properties of water. Dry sand, you could never create a vertical wall. But if you get the sand too wet and the grains get too far apart, the whole structure will collapse. It'll just flow apart, right? And the same thing happens essentially with earth. Geological structure can really influence this. We talked about this landslide into a reservoir in northern Italy, where a large section of the slope gave way because of a slip on this shale layer along that bedding plane. Here's some pictures, the reservoir before and then after. It's completely filled up with material. Yeah, that more or less covers mass transport. Really, it's all about characterization. Mass moves downhill. Gravity pulls it down. Over time, all mountains will crumble and be transported downhill unless they're continuously uplifted. Right? Blocks can just slide on a plane, or you can have this kind of almost normal faulted slumping. Right? These are normal faults functionally, and you just get kind of continuous slumping like that. Here's some pictures. These are those angled surfaces at the top of a slump. There's a person for scale there, right? Those are corresponding to these angled surfaces here, right? Yeah, so we had a lot of pictures in here. This is a channel of debris flow after the flow had ceased. Here's a very large old debris flow out into a basin. It looks like an alluvial fan, but you can tell that it happened very rapidly, all in one event, more or less, based on the weathering texture there. Creep can lead to curved tree trunks like this, or to these kind of curved beds at the top of a weathering profile. But in general, mass transport occurs. It takes material and transports it downhill. As humans, we've engineered a variety of solutions for this. Lots of them have to do with creating controlled drainage, filling in with aggregate that's more stable, and building slopes at appropriate angles. If we have to build them too vertically, supporting them with things like rock bolts that go deep into the rock, and drainage systems that allow water to come out. Also, these kind of engineered building materials and products like this mesh that would be filled in and help stabilize that terrain there. On a larger scale, what we've done is built debris basins and dams. And so here's a map of Claremont. And so this is San Antonio Canyon coming out of the San Gabriels here into the valley. And the city is just built on this alluvial fan. You can see the topo lines there, these kind of widely spaced lines. That's indicating that this is just this debris fan, alluvial fan that comes out of the canyon. But we've built this structure in here to prevent the transport of material, debris, out of the canyon. And so each time there's a storm and this basin fills up with debris, city workers go in and they empty the basin. They literally dig out debris, put it in dump trucks, and transport it away. They probably use that for building aggregate and things like that in other places where it's needed. But continuously, this basin fills up with debris, and then we empty it over and over and over again. This is what it looks like down there. And as the snow melts this year, there will be, to be sure, there will be lots of debris flows and probably lots of flooding as well. We've done this all along the San Gabriels. Here's a large debris flow basin that's over in the San Fernando Valley. Huge, right? And so they built 2 dams up in the mountains in this canyon, but all of the mass that comes down out of there stays in this channel until eventually it ends up down in here. That's a close-up of that. There are quite a few examples of that out in the along the southern side of the San Gabriels, north side of LA, the greater LA area. In any case, that really captures the majority of mass transport and what I want you guys to know about it. So yeah, we'll cut it off there.